Welcome to Science and Nature. This is a very special occasion. This is the 300th show in the series since the program and its predecessors have started, and we'd like to welcome you to another exciting show. We have a guest who's been here before, Professor Dorothy Godfrey-Smith, who's going to be talking about a topic near to her heart and dear to her heart. It's shedding light on the past, this time looking at the old world and looking at a technique referred to as luminescence dating. Welcome to the show.
I'm very happy to be back, Andrew.
Okay, you've got us here. What is luminescence dating?
Well, pun strictly intended, I might say it is a very stimulating technique.
I see.
And that is not because we're applying the technique to dating, but simply because in order to measure an age using this technique, we need to stimulate the sample, either using light or using heat. To begin, why don't we turn to the slides, and I want to ask the question, referring back to radiocarbon dating. Now, when we talked about radiocarbon dating, you'll recall that we talked about that as a technique which was suitable for dating organic samples,
yes,
which are between 300 years and roughly 40,000 years old.
Yes. Now, these artifacts you have here don't look very organic, do they?
No, and what we have on the slides here is a set of teeth from various mammals dating to the Quaternary. And so the question is, what if the samples that we want to date aren't suitable for radiocarbon dating? These teeth don't have very much carbon in them, so they can't be dated using radiocarbon. What if the samples are too old for radiocarbon dating? This is a hominid mandible, that is a jaw of a proto-human, which turns out is greater than 40,000 years. It can't be dated absolutely using radiocarbon. What if, in fact, the sample that we want to date is completely inorganic, such as a ceramic artifact might be?
Yes.
And finally, what if the sample is contaminated with modern material, clearly so, such as this little aspen growing on an old log? Therefore, the log can't be dated by radiocarbon dating because it wouldn't give the correct age.
Right.
Well, the answer is, and if we can pan back on this slide, dosimetric techniques to the rescue.
Okay.
Okay? And the dosimetric techniques are called dosimetric because what they do is they measure the radiation dose absorbed by minerals, by natural minerals. Okay? There are three techniques in this group. The top one, optical dating, known also as optically stimulated luminescence. This depends on measurement of samples which are zeroed by exposure to sunlight.
Okay.
And that's why there's that little sunshine there next to it. Thermoluminescence, or TL dating, is a technique suitable for the dating of materials zeroed by heat.
Okay.
Okay? They are the match. And electron spin resonance is the third one, which measures the time of creation of the mineral, such as the growth of coral or the growth of tooth enamel, which is hydroxyapatite,
Okay.
in organic or inorganic situations. Okay. On the next slide here, what we have is the age equation, which actually shows that we need to perform two kinds of measurements. First of all, we need to measure the total past radiation dose that was absorbed by the mineral since the clock resetting event.
Okay.
And secondly, the rate at which this dose is being absorbed from the environment.
Okay.
So let's just very quickly go over the dose rate part. The dose rate equation is a great big scary looking equation with lots and lots of variables, but essentially what it means is that the total dose of radiation which is being absorbed by the mineral in question has four components, and these depend on the amount of uranium, thorium, and potassium in the surroundings, plus a small component of cosmic radiation that comes through the atmosphere and penetrates the first few meters of the Earth's surface.
Well, this is why the altitude and the latitude and the
That's right,
Yes.
and sediment density, and there is a water component, a moisture component
Okay.
also included in this whole thing. Okay, let's talk about thermoluminescence dating first. Okay. Thermoluminescence dating has very many applications. Now, for example, it's the perfect technique for dating directly objects created by human beings by firing of clays. In other words, all manner of ceramics and not only pots but tiles and other types of objects, figurines.
Right. This is a Roman artifact, is it?
This is a little pot of Roman age,
Yes.
and I guarantee you that it is of Roman age because you will see here in its base is a little hole. Okay.
Sampling technique, is it?
There's the sampling. I
Yes.
drilled out a very tiny amount from this pot and analyzed it using thermoluminescence.
Okay.
Now, TL dating has very many applications, and we might also, if we were inclined to do so, date these ceramic sherds which come from Caesarea in Israel, around Haifa. And this is an archaeological site which has been occupied by many different cultures, not only the Romans, but Muslims, the Sultanate, the Crusaders, and people since then.
Yes. You don't have to worry about contamination then as much with contamination as with carbon dating, I assume, in this case.
No, there is no problem with contamination in this case, but because this is a set of sherds which I collected from the surface of the site,
Yes.
any of these could be any age
Ah,
during the time of creation of the site. So I couldn't date one of them and say all of them are this age. I
Yes.
have to obtain a distinct luminescence age, TL age, on each sherd separately. And I would likely get different ages dating to the various different occupations of that particular site, which was very large and occupied for a very long time.
Right.
Okay. Now, can we look at the slides, please? Now, this slide here shows the very many different applications of thermoluminescence dating. And right in the middle of the slide, it highlights naturally occurring phosphors. The most common naturally occurring phosphors are quartz and feldspar. Those are natural minerals,
Right.
which are the most common in the Earth's crust. Therefore, they're present in ceramics, they're present in other materials, they're also present in the rhyolitic type of volcanic materials,
Right.
and therefore volcanic materials can be dated using TL. This next slide here shows how the technique is applied, and this is actually the set of TL glow curves, that's thermoluminescence glow curves, which are heated to about 500 degrees at a constant rate, and the luminescence is the light emitted by the sample while it is being heated.
Right.
The yellow curve shows the natural luminescence from that little buff pot I just showed you.
Right.
The green curve shows the luminescence from the same sample that has been irradiated in the laboratory additionally. And
I
the
see.
age is obtained by looking at the ratio of one over the other.
At any given temperature or throughout
Within
the
the
whole?
temperature range greater than 250, and for this sample less than 450 degrees.
Okay.
Okay, and that actually gave me you notice that that sample was irradiated with 8 gray. A gray is simply a unit of radiation dose.
I see.
Now, a typical dose rate for ceramics and sediments is about 4 gray per 1,000 years.
Okay.
So if you look at that slide again, you'll see that 8 gray dose roughly doubles the intensity in that high temperature range,
I see.
which tells me that the sample must have received about 8 grays in nature,
In the first
and
place, yes.
therefore it is about 2,000 years old,
Based on that rate, yes.
based on that dose.
Right.
We can also, and have done, applied TL dating to ceramics from Canada, from Nova Scotia. This is a set of ceramics that I worked on with a colleague from Memorial University. My colleague Mike Deal was the excavator, and I was the geochronologist at this site. We dated 5 sites, 5 ceramics. Those are the sherds we worked on. This is the location of the St. Croix site. It's the same site I discussed in
your Eller's house.
My previous
Yes.
incarnation. Essentially, this site was discovered in the 60s by John Erskine, but it really wasn't excavated until the early 1990s. A lot of ceramics have been discovered there, recovered there, a great number of lithics. The site has shown evidence of having been occupied for a long time, but because the radiocarbon datable material was quite disseminated and quite mixed, it wasn't really possible to date it using radiocarbon very securely. So we chose a series of ceramics attributed to different stylistic periods.
Right. That's based on the ornamentation on the
based on the
pot,
ornamentation. That's right. And just let's look at the age summary for this little project. It shows the age along the right-hand side column for these 5 sherds is given in Ka. That's a unit of thousands of years.
Okay. Well, kilo-ani or whatever.
Kilo-ani, that's right. So what it shows is that the youngest of these ceramics is just over 1,100 years old.
Yes.
And the oldest is roughly 2.6 thousand years old.
So that's plus or minus an error of around 10 or 15%, depending on...
That's correct. The luminescence dating techniques, because they rely heavily on dose rate parameters, which do tend to vary with time, is what is known as a low precision dating method.
Okay.
And all 3 of these dosimetric techniques carry with them an error in the age estimate of 10 to 20%.
Right. Okay.
Now, I just want to show this one because this was very gratifying to observe. We have ceramics which appear to show that the site context was undisturbed. In other words, if the site context is undisturbed, you expect the age to increase with depth of ceramic that was recovered, and this is in fact what we found at this site. The increase is not entirely monotonic, which indicates that the sediments were being deposited rather slowly initially and more quickly in the more recent past, perhaps due to some climate change, a little...
Or change in agricultural patterns and a variety of things,
That's right. Okay. Well, this slide, although a little dim, takes us to rather a different part of the world. The large river snaking along the lower left center is the Nile, and heading back off the left side of the screen up slightly rightwards, this is the Eastern Mediterranean, and it shows us the Levant corridor.
So the large body of water in the middle is what? That
is the Red Sea.
The Red Sea there, okay.
Yeah. Well, I thought I'd talk about this because thermoluminescence dating, if we could pan back to show that we are centered now squarely in the Middle East. This is the old city of Jerusalem. And in the Levant corridor, TL dating has been applied to date something quite other than ceramics, and that is burnt flints.
Okay.
As I've mentioned at the very beginning, the zeroing event in thermoluminescence is heat.
Yes.
And therefore, any natural material, quartz, feldspar, rock, ceramic, or even flint, which is heated to improve flaking qualities, can be dated using thermoluminescence.
Or during the sacking and burning of places as well.
Probably wouldn't get hot enough in that case. But you know, these flints that are, this is English flint, I
Yes.
might add, but in the Levant there are plenty of natural flint deposits because many of the mountains are limestone, they're calcium carbonate.
Similar ages, similar type of material?
Well, as far as geological age, I'm not sure,
Okay.
probably a similar age. Natural flint does not have ideal flaking properties, but they can be made better by heating the flint to quite a high temperature.
Yes.
That tends to make it more isotropic, finer grained, and it turns it reddish in color, so it also makes it quite easy to recognize
Oh, I see.
in archaeological context.
I see. So if it's untreated, essentially it'll fracture in large conchoidal planes, the conchoidal fractures. Otherwise, you can, once you heat it, you can do finer retouching,
Very
essentially?
fine
Okay.
retouching, that's right.
Okay.
Okay. And within the Levant corridor, there are some very interesting questions regarding the evolution of modern humans and the replacement of prior population of hominids, which were the Neanderthals, by modern humans.
Yes.
Without going into the great details of this question, which is addressed by certainly people who have far more experience than I on the subject, what I have on the slide here is one of the very important deep stratified sites in Israel known as Tabun. And Tabun is a Neanderthal site that is hominid fossils have been recovered from it, which are identified as Neanderthals, the pre-modern forms of humans or hominids.
Rough vintage on Neanderthals is?
Well, at Tabun,
okay.
using the TL dating on burnt flints, these Tabun Neanderthals were dated to between about 150 and as far back as 325,000 years.
Quite a long time then.
Very, very long. But interestingly, at the Kibera site, which is not very far away, the Neanderthals were also recovered. They were dated, also using flint dating, to between 48 and 60,000 years.
Very
So
different
that
site.
indicates that Neanderthals were in the Levant corridor for a tremendously long period of time.
Yes.
Even more interestingly than that, modern humans, morphologically modern humans, or practically modern, perhaps not dressed the way this man is.
Yes.
Can we see the slide, please? Have been dated at another site, Kafse, and a fourth one still known as School, to between 90 and 120,000 years.
So the overlap is there, yes.
The overlap is tremendous.
Yes.
And this is a very big question in human evolution and in the issue of human migration out of Africa, the evolution of modern humans, where it took place, when it took place, and how modern humans made it into Europe, in fact.
Yes.
Okay? Neanderthals are associated with what is known as the Mousterian. And within a few thousand years, at the very end of the Mousterian, there is a change in the technology, the artistic technology, the archaeological deposits, and along with that, there is a tremendous change in the morphology of the humans, to modern humans, to what is known as Cro-Magnon humans.
Very significant dates, yes.
Now, let's move along from TL dating to optical dating.
Okay.
And the question here, which I'm illustrating with this set of artifacts from Border Cave, is what if these artifacts were not made from stone that was burnt?
Okay.
The stone was good enough not to need burning,
Yes.
such as these ones. Border Cave, incidentally, is a Middle Stone Age archaeological site in South Africa.
Okay.
Okay. This is what it looks like. It has a very difficult approach.
Precipitous, yes.
Oh, yes, it is.
Yes.
And the best way to get to it is in the dark with your eyes closed,
I see.
where somebody shines a flashlight and says, put your foot there.
Yes.
Now put your foot there. And as you move your foot from one place to the other, you step over literally a few hundred meters of space
Yes.
without
If you
even
don't see it,
knowing
you don't have to worry about it, yes.
That's right.
It's a very significant site then. Okay.
It is. It's very large, and you remember I showed the mandible.
Yes.
early on today? Well, that was from Border Cave.
Okay.
That's a Border Cave hominid, which is modern in morphology,
Yes.
but it appears to predate 40,000 years.
I see.
So the question is, when did modern humans appear in Africa?
Yes, so this is pre-carbon dating as well, then, at 40,000.
Yes, it is.
Mhm.
I'm just going to move over a few of these slides here. Okay. Essentially, what I want to get at here in this slide is that there is another approach. Optical dating
Yes.
will date sediments rather than burnt materials.
Okay.
And the zeroing event here is exposure to light.
Yes.
The exposure to light takes place when the grains that eventually make up either an archaeological or geological deposit are exposed to ordinary daylight
Mhm.
while they are still adhering to their previous incarnation, such
Yes.
as this rock face, or while they are being transported, if we pan back, either by wind or by water to their final resting place. Once they are covered up and in the dark, they are no longer zeroed, and they can accumulate that radiation dose from their surroundings.
Now, the zeroing, this is something that takes a long period of time, or it's something that several minutes, several seconds, or you're looking at
It's
days or hours, or what?
Tremendous. Okay. I've been doing luminescence now for over a decade,
Yes.
and this is actually the first experiment that I did, and I didn't bring a slide to show you, but
Yes.
zeroing in optical dating takes place so quickly that over 90% of the signal
Yes.
disappears within the first few seconds.
Uh-huh.
Okay? Now, in contrast, thermoluminescence, the TL signal, is also sensitive to light, but not nearly so.
Yes.
And it takes several minutes for that signal to even start decreasing. So there is a tremendous difference in sensitivity of the two techniques to light.
Right.
What it means is that collecting samples
Becomes quite a challenge.
using
yeah.
optical dating, if we can have this slide here, this is sample collecting at Katupan, also in South Africa, and
Right.
believe it or not,
You're in there somewhere, are you?
between
Yes.
the two gentlemen am I.
Yes.
Okay, underneath that big
You're actually collecting.
big
that's,
fabric,
yes, okay.
that's right. Very, very careful steps must be taken to prevent any exposure to light
Yes.
of the sample
Yes.
while it's being collected.
Yes.
It's got so that I now carry with me an especially dimmed flashlight with lots of orange and red filtering in front of it, so
Right.
I can actually see what I'm doing under
Yes.
there.
This is dark lighting things, yes.
But what this means is that this technique is wonderfully suitable to date just about anything that would have been exposed to light
Yes.
during transport.
These are
So-
volcanics, are they? Or?
No, these are very coarse, heavily cross-bedded sand dunes
Okay.
on the coast of the eastern Mediterranean.
Mhm.
And dune deposits are excellent. Now, in some parts of the world, dune deposits consist only of quartz.
Yes.
Quartz bleaches extremely quickly, and therefore one is very secure in knowing that anything in the dune really has been exposed to sufficient light, well, especially if it's in the Mediterranean.
one would
They don't
suspect,
have
yes.
much cloud cover over
Yes.
there. So dunes, but not only aeolian deposits or subaerial deposits such as dunes,
Yes.
lacustrine deposits and various kinds of other water-laid deposits can also be dated. This is a set of samples from Quebec near Pierreville, and the writing on the slide actually shows not only the sample name, but the 1 and 2. The little W there refers to a winter varve, and the S refers to a summer varve.
Yes.
In varve deposits, there is a very distinct difference between a thin, dark winter deposit,
Yes.
which is laid down very, very gently,
Yes.
and a summer deposit, which is typically coarser,
Yes.
lighter in color,
Yes.
and much thicker.
And energetics and productivity. Type
That's
in.
right. And so by looking at the difference in the luminescence properties of these two varves, I can actually determine how much light this particular lake deposit has been exposed to. Now, I got correct ages, concordant ages on both varves using
Yes.
optical dating, but using thermoluminescence dating, we only obtained the correct age for the winter varf, but the
Right.
summer varf gave an age far in excess of the expected age,
Yes.
indicating that it didn't experience enough light
Yes.
to be dated correctly. Here, this slide is shows the sample collecting of, not for luminescence dating, but I included it because it shows a paleosol bedded, that is an
Yes.
ancient soil horizon bedded in between two sand dune deposits.
Right.
Again, we can date paleosols using luminescence dating,
Right.
even when they don't contain any organic materials. In
Yes.
fact, I might stress that this method is particularly well suited to the dating of inorganic deposits.
Right.
And finally, we can date sediments laid down on the Bay of Fundy, and if we were to core this sediment, we could date well underneath it. Now, this is a sandbar on the bay. The gentleman on the right is not doing a
He's not
jig.
dancing yet. Yes.
He is showing how deep the water will be in another half an hour after
Yes.
the picture is being taken. But you can see that this sandbar is being exposed to daylight on a twice daily basis,
Yes.
and therefore any surface deposit will have been exposed to
Or on a
sufficient light.
or on a once daily basis.
Perhaps once
Yes.
in the day and once
Yes.
at night.
Yes.
Moonlight doesn't quite do the trick.
Yes.
However, and this will be my second to last slide, I might add that glacial deposits are not datable
Yes.
because the glacial grinding
Mhm.
will break up and create new sediment and deposit it without exposing any of it to light.
So the clock hasn't been reset.
The clock is not reset, and if the clock is not reset, you can't do it.
Gotcha.
Well, this is just a nice picture of another field photo of another cave site in South Africa, which I'm working on at present, Rose Cottage Cave near Lesotho. And it also contains Middle Stone Age culture deposits, which appear to date back to beyond 50,000 years, perhaps much older than that.
So again, quite astounding. Well, Professor Godfrey Smith, we'd like to thank you very much for sharing these techniques with us, both on the previous show with the radiocarbon dating and, of course, with the luminescence dating this time. Shows that obviously you have quite an array of tools that you can use, that you have at your disposal for both verifying and determining dates, as well as perhaps putting things into a more proper, a more correct context from previous times. In the next 15, 20 seconds, what are you looking forward to doing?
Well, I'm about to go in the field to work on an archaeological project on the Gambaga escarpment in Ghana. And I'm also working on the geochronology of another cave site in northern Israel in the mountains of the Galilee known as Hayanim Cave, which has Mousterian archaeological deposits in it, therefore evidence of Neanderthal humans, and Natufian, which is a Holocene deposit relating to modern men.
Well, wish you the best of luck on your in your excavations, and perhaps when you come back you can share your findings with us again, and thank you very much for coming.
My pleasure.